humanoid robots are different from conventional industrial robots. Shaped like and moving like people, humanoid robots can adapt to a work environment and can coexist with humans. In fiscal 1998, we began a project to develop a humanoid robotic system. Industry, the government, and academic circles joined this project. The first objective was to develop hardware and software platforms for humanoid robots by gathering all the latest technologies. The second objective was to explore fields that humans and humanoid robots can share and then prove it.
経済産業省のプロジェクトでしたから、単に新しい機械を作るというだけじゃなくて、日本の新しい世界をリードするような産業に、発展するようなものをやりたい。そのためにはですね、その5年間が終わった時に、はいこれでおしまいというような技術ではダメだと思いました。だから5年経った時にそれからあと新しい技術開発ができるようなことを考えた。
Based on this, the project used a new method that provided a common base for research and development. The first 2 years were spent creating a robotic platform to become the foundation of development. The outcome? The platform robot HRP-1. The super cockpit, or remote control cockpit, was also made. In the cockpit, the operator can do work as if he is actually inside the robot. Now, let's look at the applications of the HRP-1 robot. We developed a humanoid robot that can maintain equipment efficiently and do dangerous tasks in a plant instead of people without stopping plant operation, autonomously and by remote control. The robot does regular inspections. When it sees something that needs repair, it moves to that location. The robot senses a radio IC tag on the floor. It adjusts its positioning using magnetic sensors. Then it moves by itself along its route along sharp corners and ups and downs. The IC tag guidance system allows the operator to easily program an inspection course that suits the plant. At each inspection site, the robot transmits numerical values, such as the temperature of equipment and meter readings. When repair work is needed, the robot is guided to the site by the remote control system. For a narrow passageway between handrails, the operator can navigate the robot by simply marking 4 points on a monitor indicating the entrance and exit. The burden on the operator was reduced dramatically with the introduction of vision sensing. Now, let's look at how the robot adjusts a valve. The 2 major valve positions are marked on the monitor. Positions of the robot and its tool are adjusted automatically, and the robot begins its task. Compared to the conventional remote control method, this system made the operation faster and simpler. In order to put the humanoid robot into practical use, further development is needed in areas such as the robot's recovery after falling, automatic battery charging, and work tool changing. This system enables remote control of a humanoid robot that looks after your home while you're away via the internet using PDAs or personal digital assistants and mobile phones already on the market. You can check your home and can even let the robot do simple tasks. For example, when you aren't sure whether you turned off the kitchen stove, you can confirm it using the robot. If you left the kitchen stove on, you can tell the robot to turn it off. The robot first confirms its own position. Then it measures the distance between it and the kitchen stove using stereo image processing. And based on its measurements, it can turn off the switch. The robot can also perform other tasks, such as opening the curtain using visual processing. Performance can be confirmed from outside from the images that the robot saw and the images produced by the simulator. You can also manually make the robot do work using the robot's visual images. By manually operating the robot's hand, you can have it pick up a bottle and throw it in the trash. The system also has a home security function that detects an intruder and reports it to you. The robot immediately detects an intruder and automatically emails you that information on your mobile phone. You can see a picture of the intruder on your mobile phone as well. You can also control the robot using your mobile phone and confirm the condition of the entire room. In the humanoid robotics project, an improved version of the HRP-1 was also made. It is called the HRP-1S. Unlike the HRP-1, it can move its arms and legs at the same time. This robot has become one step closer to humans. Now, let's look at the applications for the HRP-1S. The demand for healthcare support services is growing in Japan. This because of the graying of society and the decrease in the birth rate. So, a system shared by humans and robots is needed. Such a care support service system could comprise an extended task library, a communication agent, and a remote control cockpit for the humanoid robot. First, the robot's tasks are planned with the extended task library. After confirming the tasks, the commands are prepared. Then, the commands are input to the robot for execution. The caregiver can control the robot remotely from the cockpit. The screens show the 3D images seen by the robot. Looking at those images, the caregiver can make the robot walk and command its hand movements using a simple control device. The care receiver can talk to the robot and ask it to do simple tasks. Communication agent software will listen to the care receiver, and the robot will respond to it with its voice and expressions. The communication agent enables the robot to answer telephone calls from the care receiver's family. It can show the face and the voice of the caller and join in the conversation with its movements. It can also control the work schedule set by the caregiver in advance and perform tasks on behalf of the caregiver. The robot can do exercise-like movements and greeting-like movements. These factors enable this human-friendly care support system. Humanoid robots can operate industrial vehicles in a dangerous environment instead of people. An operator can command a humanoid robot using a remote control device called a master arm and have the robot operate an industrial vehicle. This system enables the operator to remote control an industrial vehicle instantly. Because the remote control device is light and portable, it can easily be transported to a work site. The robot is climbing up the stairs. It senses the mark on the floor at the entrance of the operator's cabin, judges its own position, and enters the cabin. The robot bends forward while keeping its balance and takes the operator's seat. The seat is made to support the robot. Various tests confirm that the seat would protect a robot from vibration and shocks. The robot is equipped with special hands to support its weight. First, the robot uses its right hand to support its body. Then, receiving a command from the master foot, the robot moves its feet forward for further support. The task begins. The robot moves the travel levers. The operator looks at a 3D display and controls the robot with the master arm. Command signals are sent by radio. The robot uses the left and right levers and excavates the ground. The operator can feel the force applied to the robot hands through the master arm. Protective clothing guards the robot from rain and fine dust particles. It dissipates heat well and is designed with the robot's movements in mind. A test in an artificial weather chamber proved that the protective clothing could withstand torrential rains. Using the same system, the robot operated a forklift as well. One characteristic of the system is that it enables a single robot to operate a variety of industrial vehicles. There are high expectations for the application of this all-purpose humanoid robot vehicle operation system in the near future. Using the HRP-1 as the base, we improved its functions dramatically and developed a new type of robot, the HRP-2. It's smaller and lighter and carries no backpack. Its axis can bend in 2 directions, and it moves a lot more like humans. Finally, let's look at the development of the HRP-2 humanoid robot. If humanoid robots were introduced at a building construction site, they would contribute to both labor saving and improve the shortfall in workers. Let's look at the robot's collaborative work with an operator when mounting panels, its skill to walk on uneven surfaces, and its skill to recover from falling. First, the panel mounting work, done in cooperation with the operator. The HRP-2 confirms the position of the panel with its stereo vision system, generates a walking pattern, and operates on its own. Voice commands can be used, and the robot recognizes them. The person can control the robot by the force he applies to the panel. When the person pulls the panel, the robot pushes it. When the person changes direction, the robot too changes direction. It's a cooperative effort. Because the robot's arms absorb vibrations while walking, it can perform tasks smoothly. Robots and humans can work cooperatively, and this will increase opportunities to put robots into practical use. When walking on uneven surfaces, the robot confirms the condition of the surface with its stereo vision system. When it cannot recognize the surface condition, it controls its feet to meet the ground properly. Even if there is an unexpected unevenness, it can walk safely. To recover from falling, the robot smoothly changes its center of balance and its position to support its body. The HRP-2 is the world's first humanoid robot with a height of over 120 centimeters that can recover from a fallen position by itself. We also developed technology to ease the shock from falling down. The robot quickly assumes a squatting position, controls its balance, and takes a sitting position. These technologies enable the robot to get up even if it falls and resumes its task. This is the movement of the HRP-2 simulated on a computer. The operator can move the virtual robot on the computer screen using the same software used to control the real robot. Using a device called the Virtual Robot Platform, the potential for humanoid robots is being pursued.
ロボットを作って売るというだけじゃなくて、それにどういうような仕事をさせるかというソフトウェアの話があるし、いろんな目とか手とかオプションをどうやって作るかという話もあるでしょう。それからそれをレンタルリースするような仕事もあるでしょうし、それから故障が起こった時にそれをメンテナンスする仕事もあるだろうというようなわけで、コンピューターと自動車産業を合わせたような広がりのあるたくさんの人の雇用機会を創出するような産業になるんじゃなかろうかと。
The graying of society and a decrease in the birth rate are becoming major problems in Japan. Can robots become more like humans? Can they become an alternative labor force? What is their potential? Is it something that can't be found in people? Our 5-year development project ended, but we are now standing at a new starting point.